A1, multiplying and dividing rational expressions. So by the end of this lesson, our goal is to be able to simplify rational expressions and simplify complex fractions. So that's what a rational expression is. And all it is one polynomial divided by another polynomial. Right, so if I give you 3x minus 2 over 4x plus 5, that's a rational expression. Or even 2 over x plus 1. Rational expression. Now the way we simplify rational expressions, same way we always do. Right, if you have a number, you just figure out what the biggest thing that goes in both of them, in this case 4. So you divide both 8 and 12 by 4 and you get 2/3. Now, similar idea if you have a polynomial. So in this case you have to factor. You can't just cancel things out. I hate when people do that. Right, you gotta factor. So again, x squares don't cancel, x's don't cancel, it doesn't work that way. You gotta factor. And that's gonna be a big thing this whole chapter, is to know how to factor. So we factor it, hey, these cancel out, and then you get your answer. That's a general idea. And there's also the same thing if I give you variables. Let's say I give you a squared b over a cubed b squared. Right? We reduce this, you reduce these. In this case, I always say which one has more, bottom or top. Bottom has more by 1, so 1 on the bottom. Which one has more, b or b squared? B squared does by 1. So I guess something to that effect. Okay, so now let's do a formal way. Let's talk about a formal way actually of simplifying this stuff. Now before we do that though, we gotta talk about something very important. It's what's known as, under what conditions is the expression undefined? We call this a restriction. Restrictions. That is right, we're dividing here. And you can't divide by everything. There's one number in particular we can't divide by. That's when the denominator equals 0. Right? You can't divide by 0 on the bottom. So restriction, all we're going to do is the denominator equal to 0. And that's how you can find our restrictions. So in this case, right, just set each one of these equal to 0. So my restrictions are going to be, let's say not equal to 0. Right? Your numbers can't be 0. So set this one equal to 0. And you're going to get z equals 1. Or actually can equal 1. Restriction. Z plus 5 can equal 0. So z cannot equal negative 5. And then z minus 2 can equal 0. Z cannot equal 2. So those are our restrictions. Right? So, and that's actually the first thing we do in all this stuff. And finding restrictions is the first thing we're going to do in all these problems. Right, so the way we're going to do these problems are steps. Step 1, we're going to find restrictions. Right, which again, just set the denominator equal to 0, because we cannot divide by 0. Or set the denominator not equal to 0. And then we're going to do everybody's favorite thing in the world. We're going to factor. Then we're going to reduce. Right, so in this case, I found my restrictions, right, so the denominator equals 0, right, I can't divide by 1, can't divide by negative 5, can't divide by 2, because that would make any of these 0 on the bottom, and I can't do that. Next, we're going to factor, we can factor this. Look, that's not too bad, right, we just got to figure out two things that multiply to get negative 8, but add to get 2, and that should be z, it's 8 and 2, so z plus 4, 4 and 2 is what I meant, and then z minus 2. Again, the 4 is positive because the middle sign is positive. The bigger number is always what the middle sign is. So, we factor and we get this. All over z minus 1, z plus 5, and z minus 2. Now is my favorite part. It's going to be yours too. We cancel stuff out. Z plus 5's cancel. Z minus 2's cancel. And left with just 2z, that's a 2, not a z, z plus 4 over z minus 1. And that's how we reduce and simplify an expression. That's what I meant to say. That's how we simplify an expression. So move on to the next one. So in this one, right, remember that we start the same way. We had to find the restrictions. In this case, we have to factor at the bottom. So maybe I should put factor first. Factor first, actually. So let's factor the bottom here. So I have 15y squared, that's already good. Here I gotta think of two things: to multiply to get 32, but add to get negative 12. It seems like 8 and 4. So y minus 8, y minus 4. Remember, they're both negative because that's a positive. The only way you get a positive at the end is if they're the same sign. And the middle one's negative. So I factored the bottom. Now we split it, and my restrictions are going to be, well, here's a trick, right? Anytime there's no plus or minus, it's always a 0. So you set equal to 0, divide by 15, square root it, you're going to get 0. So y cannot equal 0. Solve that one, y cannot equal 8. And that one, y cannot equal 4. So those are my restrictions. It can't be 0, 8, or 4, because any one of those would cause this to not exist, because you can't divide by 0. Right, now let's factor the top. Same idea here. I need two things that multiply to get negative 24, so different signs. That to get 2, so that is 6 and 4. So it's going to be y plus 6 and y minus 4. Remember, same idea. Negative 24 should be different signs, and the middle one is positive, so the bigger number should be a positive. So I have all this. Now let's reduce. Only thing I see right now is y minus 4s and the y minus 8s. So now I'm going to put everything over. So I have 3y, y plus 6, 15y squared. Now, and then I'm still not done. Now again, to remultiply, so I can reduce this. 3 and the 15 reduce to 5. And then again, I have a y and a y on the bottom. So which one wins? The bottom wins. There's one more on the bottom. So I should get y plus 6 over 5y. And I cannot do anything there. Remember, do not cancel this out. I do not want to hate you for life. This is not a thing because it's plus. These are locked in, so you can't do that. This is your answer, right? Anytime there's a plus or minus sign, it's locked in. It's a binomial. It cannot be canceled out with the y on the bottom. So please, please, please don't do that. Next one. So this is a multiple choice. All they want to know is when is it undefined. So remember that's when the denominator equals 0. So it's, or doesn't equal 0 actually. Let's worry about that. So first, let's factor this. Two things that multiply get 10, but I have to get negative 3, so different signs. X minus 5, x plus 2. Now, right, set the bottom equal to 0 and split it. So I get 0 equals negative 6, 0 equals x minus 5, and 0 equals x plus 2. So I get x equals 5. Well, actually I should say can't equal 5. X cannot equal negative 6. And again, 0, see here, that's not a thing. 0 does not equal negative 6, so I'm not worry about that one. Just worry about these. So 5 and negative 6, which is, why did I say 6? I found it, negative 2. I don't know why I said that. So G would be my answer, right? 5 and negative 2 are the ones that can't be, are the undefined. So let's talk about a trick that we all should learn in algebra that's going to help us here today. And that's factoring on negative 1. So what's that about? That's about when you have things that almost could cancel out, but they're off by a sign. So you say like this. Like, oh, they're the same things, but the signs are off. What we could do is we call it factor on negative 1. So you factor out negative 1, pull a negative 1 out, and put it down here actually. What does that do? Well, that changes all the signs. That's a negative 2 and a positive x. Or to rearrange it to look nicer is x plus minus 2. Right? So now these match, you cancel them out, and you get 1 over negative 1. That's the trick of factoring on negative. You pull a negative out, it switches the signs, and you're good to go. So let's look at this example here. Now, let's do proper etiquette. I should find my restriction first. So z cannot equal 0 from here, because there's nothing there. Set equal to 0, square root it, blah, blah, blah. This one, set equal to 0. Add x to both sides, and you get 4. So those are my restrictions. Now let's factor the top. These both have a z. So z x minus 4, z squared, 4 minus x. And now notice again these two. Well, these reduce. But right here, they're so close to canceling out, there's opposite signs. That's where you can use the trick. We're going to factor out negative 1 from the top or the bottom, doesn't matter. You can switch these. And that's what it does. It makes this a negative, makes that a positive. That's what factor out negative does. So let's switch them. Makes it easier. And then that's still 4 minus x. These cancel. I just get negative 1. Almost forgot that, just so z there. Over z. With these restrictions. Same thing here real quick. Right? Notice I can factor the top. Well, first my restrictions. This is the bottom equal to 0, not equal to 0. So subtract 5, you can't be negative 5. Add 5, you can't be 5. Other than that, let's factor the top. These both have an a and a b in common. So you get that. Over 5 plus b, 5 minus b. And again, notice these two almost can cancel out, but they're opposite signs. So let's factor a negative on this. That would make that a negative, that makes that a positive. So we just rearrange it like that. Now these cancel out. And that's the only thing that cancels out. Everything else stays. Negative AB over 5 plus B. And again, this is locked in, so it cannot cancel out with the B up there. That's the idea of how to factor out a negative one. It's a nice, handy trick. Next up, let's talk about how to multiply rational equations. Just like we always do, right? When you multiply fractions, you just multiply across. You could, if you want, you could cross reduce. Like these could go 1 and 2, and this could go 3 goes in there, 3 and 5. So you get 5 over 6. But the general idea is just multiply across and then reduce. So I don't care if you want to reduce first or you want to reduce later. And then remember when we divide, you multiply by the reciprocal. Let's keep that in mind. Or the same idea, just to multiply by the reciprocal. So you're going to flip the right hand side. Let's just say of right hand side. Alright, so you flip the right hand side, so you get this. And then same rules apply. So let's do an example. Now first, you can't forget restrictions, right? So I'm going to look at this. And again, you set it equal to 0. Not equal to 0. And then you go AB cannot equal 0. Same thing here. You just go CD cannot equal 0. So my restrictions, anything in variables in the bottom, they just cannot equal 0. And actually, you just say A cannot equal 0, B cannot equal 0, C cannot equal 0, and D cannot equal 0. Right? It's all separate. So let's multiply these. I didn't want to put restrictions. Anyway, so to make it easier on myself with the numbers, I'm going to cross reduce, right? So 20 and 14, I can divide them both by 7. So 7 goes to 14 2 times, 7 goes to 21 3 times. 12 and 8, I'm going to divide them by 4. 8 goes into 4 2 times, 8 goes into 12 3 times. 4 goes into 12 3 times. Hey, then look at, they reduce even more. 3 and 3, 2 and 2. So all the numbers are gone. They all reduced out. Now I'm left with this. This multiplies across. I'm going to get a squared b c cubed d all over a b c squared d. Now we have the variables. Let's just do what we always do, right? If I'm looking at the a's, I try to figure out which one has more. The top has more by 1. So I'm going to have an a on top. The b's are both 1, so they cancel each other out. On the c's, I have one more c on top also. So there's one c on top. And then my d's, there's one more on top. So my answer is A, C, D. Over here. Now we're going to ignore the restrictions because they don't really care about it. They actually didn't ask about it. But the way we do the problem is still the same. Right now, notice this divide sign, so we're going to flip the right hand side. So 16m t squared over 21 a4b cubed times the reciprocal 7a squared b squared over 24m cubed. And again, I like to do the numbers and variables separately. This makes it easier for me. So with my numbers here, 7 and 21 they do cross reduce 1 and 3. Now 16 and 24 they reduce also. Now remember, you can always reduce up and down or left and right, just not on the same. They can't both be on top or bottom, but top and bottom anyway works. Just like we did up here, right? The 3's canceled up and down, up and down. We also reduce diagonally. 16 and 24 can both be divided by 8, so 16 by 8 is 2. 24 divided by 8 is 3. So let's carry this over. I'm going to have 2 on top with an a squared b squared m t squared. And on the bottom I have 9, it's 3 and 3, with an a to the 4th, b cubed, m cubed. I always think doing the variables by themselves is a lot easier. Because all you have to do is go, okay, which one has more? In this case, the a's, the bottom has more by 2. On the b's, the bottom has more by 1. The m's, the bottom has more by 2. And then there's only 1t on top. Only t is on top. So on top I have 2t squared. On the bottom I have 9a squared b m squared. And that's my answer. Right? Divide means flip the right hand side. With numbers, you just cross reduce or multiply them across and then reduce it. Variables, it's always just easier for me just to put them all at the end and then just figure out which one has more. But that's how you do it. Numbers, which actually for a lot of people is a little tougher than doing it with polynomials like this. Right? Because this we know the way we're going to do it. We're going to factor it and then we're going to find the restrictions, then we're going to multiply. So let's do that here, right? Let's first factor it. Step 1's factor it. Right? So let's factor this. Two things to multiply get 35, add to get 2. Plus 7 and minus 5. Right, again, different signs. And notice the middle one's positive, so my bigger number is positive. Let's do the same thing here. Oof, I did not. That was terrible. Me trying to highlight. Two things that multiply to get 10, but add to get negative 7. Notice there's a positive 10, so they'd be the same sign. And then since the middle one's negative, they're both negative. So x minus 2, x minus 5. Here, a lot of people overthink this. What they have in common? There's only two things. And they have a 4 in common. So you're going to left with 2x minus 5. Over here, what do they have in common? They have a 4 in common also. So you have x squared minus 16. X squared minus 4. And then you can actually factor it some more. It's a difference of 2 squares. X minus 2, x plus 2. And now since it's all factored, I can do my restrictions. Very simple. Right? X cannot equal just what makes the bottom 0. Negative 7, 5, 2, and negative 2. Right? Anything that makes the denominator 0 is your restriction. That's it. You can't beat those numbers. Other than that, let's just solve it. Let's do the fun part. What cancels? X minus 2 and x minus 2 cancel. Hey, the 4 and the 4 cancel. X minus 5 and x minus 5. Look what divide the massacre. 2x minus 5 over x plus 7, x plus 2. Remember, that's it. We can't do anything else. These are all locked in. That's our answer. Right, and you get something like this and like, oh, that looks ugly. It's the same thing. You just factor. A little faster now. We got two things to multiply to 21, but add to get 10. So 3 and 7. Right, it's an easy one. They're all plus, so you know it's 3 and 7. Up here, you have to multiply two things multiply to get 20, but add to get negative 9. So again, notice same sign, but a negative, so both negative. 5 and 4. X minus 5, x minus 4. I love factoring. Oh, it's a divide sign. Almost missed that. Let's flip this. That's the first thing we're going to do here. We actually have to flip this. Should have done that first. Jumped the gun a little bit with my factoring. So excited. So we flip it first, and then we could factor. The bottom here has two things to multiply to get negative 12, but add to get negative 4, negative 1. I had the answer in my head. Negative 4 and positive 3. Again, notice middle is negative, bigger sign's negative. They're different signs because that's a negative at the end. Here's only two things, so let's figure out what they have in common first. And they have a 2, 6 in common. Haha, I'm good at math. X plus 7. Right, so again, now before I move on, I should move this down here. Right, this is our factored form. But before we start canceling, we have to find the restrictions. Again, super simple. Just what makes the bottom 0. So in this case, negative 3, negative 7, 4, and we already have negative 3, so it's just these. Now let's cancel everything out. So let's see, x minus 4's cancel, x plus 7's cancel, and that is it. On top we are left with the 6 right there, x minus 5, and on the bottom I have 2x minus x plus 3, so we can be a little fancy with this. And I get that. And that's how we simplify. The next few, I'm going to rewrite it. I'm not going to spend, actually this one I have to do. So this is the next one. First, don't get freaked out by this negative 1 here. Right? Remember what negative 1 power does? It just flips it. So it's a reciprocal function, right? So it flips it. So that means that 2x squared minus 15x plus 7 is on top. And the 2x squared plus 7x plus 3 is on the bottom. That's what the negative 1 power does, it flips it. And then this stays the way it is. So we get this. And like we always do, let's factor everything. That's our first rule. So 3 minus x, 3 plus x, the difference of 2 squares. You know it's funky, it's still different 2 squares. 9 to the square and x to the square. Down here, that's just x minus 7, x plus 3. Now we get to these. Oh, factor the number in front. So remember, the way I like to do it best is to multiply these two outside terms. You get 6x squared. And then try to figure out two things that multiply to get 6x squared, but that add to get 7. In this case, that would be 1x and 6x, because that multiplies to get this, add to get that. And then we plug it in for the middle here. So I'm going to get something like this, 2x squared. Instead of plus 7, it's going to be plus 1x plus 6x from here. Don't forget the plus 3. Then this is factored by grouping. These both have an x in common. 2x plus 1. Always bring down the middle sign. These all have a 3 in common. 2x plus 1. These match. 2x plus 1, x plus 3. That's what this is right here. 2x plus 1, x plus 3. Add the factor to this top also. Let's see, 2 and 7 to be 2x squared times 7 is 14x squared. Same idea, what two things multiply to get 14, but add to get negative 15. That'll be negative 1x and negative 14x. Plug it in for the middle here. So you still have the outsides, 2x squared minus 1x minus 14x plus 7. Factor by grouping, these have an x in common. Always bring that middle sign. Now this is what messes people up. Now again, look what they have in common is 7. That becomes 2x. And then here, remember, 7 divided by negative 7 is a negative 1. So these match. 2x minus 1, x minus 7. So after all that, so to find the restrictions. Again, luckily that's super easy. Just what makes it 0. 7, negative 3. It's a little tougher, right? This set equal to 0 real quick. Subtract 1 divided by 2. So negative 1/2. And then we already have negative 3. So those are my restrictions. And now we can finally cancel stuff out. Let's see, x minus 7's cancel. These don't cancel. Now look at this, x plus 3 plus x plus 3, they're actually the same thing. Because it's a plus sign, it doesn't matter. So those actually, you don't have to do that negative 1 rule. They cancel out anyway. Here, the negative 1 trick won't work, because if you flip this to negative 2x plus 1, it still doesn't cancel. So I'm just kind of stuck. That's it. I have 3 minus x, 2x minus 1, all over 2x plus 1, x plus 3. And again, same idea here. If you factor a negative to both negative, it does not cancel with that. So that's that one. Right, a lot of work, but it's the same concept. This next one, negative 2 power. So remember what the negative does? It flips it. So if y'all want, it could flip it early. So 3abc over 2xy cubed. There's still a 2 there. Remember, and this is divided by. Remember what divided means multiplied by reciprocal. So x squared y4 over 6a squared b. Now what do I do with this squared? Well, that goes to everything. Right, so that becomes a 9. 3 squared is 9. That's an a squared, a b squared, a c squared. 2 squared is 4, because that 2 goes to everything. An x squared. Y cubed squared, remember a power to a power, you multiply those, so y6. And then this side just leaves it the way it is. Now again, I always like to do variables and numbers separately, so let's do numbers first. 6 and 9 reduce. Divided by 3, get 2 and 3. And that's pretty much it. My variables left over are this. So I get 8 x squared y6 a squared b. And then let's look what reduces. my A's, they're both exactly 2. My B's, remember which one has more? The top has more by 1. There's no other C's. X squares, they're exactly the same, they cancel out. And here, which one has more? The bottom has more by. So my answer is whatever's left over. 3, B on top, only, oh, C squared, almost forgot about that. And on the bottom, 8, Y squared. But if I should have done restrictions at some point. If I do restrictions, it's just whatever. There's no plus or minus, so it's all the variables on the bottom. My restrictions would be X cannot equal 0, Y can equal 0, because it's on the bottom also. A cannot equal 0, and B cannot equal 0. Right? Because again, there's no plus or minus, it's just all the variables on the bottom can't be 0. So that's that one. This one right here, I'm gonna spare you because it'll take me like probably 10 minutes to learn this problem. But it's the exact same idea, right? You see this divide sign? You're gonna flip this. This is gonna be x squared minus 4x minus 32. That's gonna be negative 2x squared plus 5x plus 3 on the bottom. Same thing here. It's a divide, so you flip it. And then over here, that's the only one that stays the way it is. Right, again, I'm not going to do all this. I'm going to do a little bit to show you some factoring tricks, but right, what's the next step? Factor. Now, again, I'm not going to do this whole problem, but to show you. Now look at this one. Don't forget the first rule of factoring, which is, let's see if they have anything in common first. These actually have a 3 in common first. So you factor out the 3, and you get this. 6, sorry. And much simpler to factor now. You're just like, oh, it's x minus 6 or whatever, right? So don't forget to factor what they have in common first. And same thing here. Notice that they all have a 6 in common, so that's the first thing you're going to do. X squared minus 1, x minus 2. Now it's a lot easier to factor. These, you're just going to multiply first and last. Same thing here. Alright? Now again, I'll spare you that because that would take 10 minutes in itself. Let's go on to the last one. Complex fractions, which actually aren't that complex if you know the one secret. And the secret is, look at this. This is just a divide sign. That's just a divide sign. So the secret here to doing these problems is don't be lazy. Just rewrite it. That's all you have to do. If you rewrite it, it becomes not scary anymore. Right, this looks like a mess, but don't be lazy. That's just a divide sign, so let's rewrite it. X minus 2 squared over 2x squared minus 5x plus 4 divided by x squared minus 4 over 4x minus 10. Right, now it's a normal problem again, just like we did before. Oh, what are we going to do? We're going to flip this side and multiply by the reciprocal. So x minus 2 squared over 2x squared minus 5x plus 4 times the reciprocal of that, 4x minus 10 over x squared minus 4. Right? Now it's a normal problem. We went from this monstrosity to this. How do we do this? Well, find the restrictions. Well, actually, factor first. Right? Find two things that multiply to get 4, back to get 5. X minus, that does not factor. Oh, 4 and 1. Haha. X minus 4, x minus 1. There we go, the factors. Right here's the difference between two squares. X minus 2, x plus 2. Right, again, notice they're both squares and it's a negative. You can only do it if it's a negative, not a positive. Here, right, again, two things. What do they have in common? They have 2 in common. So 2x minus 5. So it's all factored. I can find my restrictions. It's whatever makes the bottom 0. 2 doesn't have an x, that's nothing. 4, 1, 2, and negative 2. Those are my restrictions from that, and that. Right? Now our favorite part. Let's cancel stuff out. Now remember, this is x minus 2 squared, so that's like saying x minus 2, x minus 2. There's 2 of them there. And one of them gets to cancel out. The 2's cancel out. And that is about it. I'm left with x minus 2, 2x minus 5, x minus 4, x minus 1, x plus 2. And there you go. That's how you do it. Let's look at a couple more, and then we're done. Right, so the last one we're going to do is right here. Same idea, right? We're going to go, okay, this is a divide sign. I could highlight. Right, so it's just x minus y. That was terrible. A plus b divided by y squared minus x squared minus y squared over b squared minus a squared. Right, we have that. Again, just that means flip this right hand side. So I'm going to get this plus b. Got lost for a second there. We're going to flip it. That's what divide means. So multiply by the reciprocal of the right hand side. Right, now before I find my restrictions, I got to factor this. So this side's the same. This side is a different two squares, right? Even though they're no numbers, same concept. I got two squares that are being subtracted. So this is x minus y, x plus y. And this is b minus a, b plus a. My restrictions, it's a little bit different here. We have a plus b, so does that work? It's not a can equal 0, b can equal 0, because it's a plus sign. So just do that. A plus b cannot equal 0. Or if you want to be fancy about it, a cannot equal negative b. Same thing here. Y minus x minus y cannot equal 0. Or if you want to be fancy about it, add the y. X cannot equal y. Same thing with that one. Y plus x plus y cannot equal 0. If you want to be fancy about it, subtract the y. X cannot equal negative y. So these are my restrictions. Either one of those gives you full credit. Right? Just whatever's on the bottom cannot equal 0. Because there's a plus sign, you actually got to solve it. If it was just a single variable and multiplying, like we did earlier, then you just list them out. Right? Because they're all being multiplied here, so anything can be 0. Anyway, once we got that out of the way, let's just do our favorite part. B plus a plus b, remember you're adding, so it's the exact same thing. X minus y, gone. You're left with b minus a, x plus y. And we are done.